Okay, we are doing ratio student handout number 3. Can a ratio help me solve problems? Alright, so this is putting what we learned for the first two, how to create a ratio, how to find equivalent ratios. Now we're going to use ratios when we're dealing with word problems. So we had this set up before where you're going to write the information you know, the information you need to know. This area is to work out your work, and this is a place for your answer, your solution. All right, I'm going to read the word problem out loud and then we'll go ahead and start. A small university enrolls in-state and out-of-state students. The number of students enrolled in their most recent freshman class was 243. The school reported that it had enrolled 7 in-state students for every 2 out-of-state students. How many of each type of students was enrolled in the freshman class? So, to start off with the information that I know that there's 243 total students. And I also know for every 7 in-state student, there was, sorry, that's a semicolon, there was 2 out of state. So the ratio looks like 7 to 2. All right, 7 in-state, 2 out-of-state. And if you're confused on what in-state and out-of-state, when you go to college, say if you go to a college and you live in North Carolina and you go to a school in North Carolina, you are considered an in-state student. So if somebody from Florida or Tennessee came to a school in North Carolina, they are considered out of state. So for every 7 in-state students, there are 2 out-of-state students. What we need to figure out how many of each type of students. All right, in state and out of state. In state and out. All right. So our plan area to work at. First, we're going to write that we know that in state we have 7 students. Out of state we have 2. So every ratio has in this scenario, this ratio has a total of how many? 7 and 2, 9. So we're dealing with 9 groups, 9 people at a time, because for every 7 students that are in the state, there's 2 out. So it's like one unit, but it's 9 of them together, but they're split with 7 and 2. So what you're going to do to figure out how many of each was in each class, we have the information of the total. We know there's 243 students. So you're going to start with in-state. You have 7 in-state, and out of the total, there are 9, right? So if you had 7 in-state over the 9 total, you know how many you're trying to get to, 243, right? This tells you how many total people we're talking about. This is going to let us know the max amount of students that we can have in-state. So to figure this out, it's just like a fraction. Sorry, let me scoot this up. How can we go from 9 to 243? This is where you're going to get out your calculator. When your calculator, to figure this out, all you would have to do is type in 243 divided into 9, and that answer is 27. So from here to go to 9 to 243, you're multiplying by 27. Whatever you do to the bottom, you do to the top. So you take it to the top, 7 times 27. And when you type that into your calculator, you get 189. All right. So there was a total of 189 in-state students. So now you have to think. We have to do the same thing with out. We have to create our new fraction. So now we're not dealing with 7 over 9. We're doing the out of state. So now we are 2 over 9. And we know our total has to be 243. So now we're seeing how many is the maximum amount of out-of-state students that we have. Same thing, we already calculated to get from 9 to 243, that's times 27. So you do the same to the top, times 27, and 27 times 2 is 54. right? So now we've created our new ratio. So our solution is that how many of each student is in each state? We know that there's 189 in state and there is 54 out of state. So your new ratio would be 189 to 54. And to check that, you need to make sure when you add 189 plus 54, you get that 243. All right? Right here, 189 plus 54, it equals 243. That's how you can go back to check it. So to go back over what we just did, we had our ratio from 7 to 2. We needed to add the total together to see how many students we are really working with. Then you compare it to the total that we needed to get. We needed to get 243. So we had to figure out the maximum amount to get to 243 for both in-state and out-of-state students. All right, let me write that. Make sure you write, this one is out-of-state. So when you go back and look at it, you know which one is which. And this is in-state. All right, moving on to the bottom. Sorry guys, I'm trying to fix this so you guys can have a good look. Alright, I'm gonna zoom in for you guys. Alright. So at the bottom it reads this word problem. I don't have to show the whole thing, but I'll give you actually I have space to show the work. So it says a junior high is interested in changing their student to worker ratio in the lunchroom to cover in order to move students through the line quicker. During lunch, there are 45 students for every 2 workers. If there are 215 more students than workers, how many students and workers are in the lunchroom? So we have to, this bottom part is the key thing. If there are 215 more students than workers, how many students and workers are in the lunchroom? So this problem is a little different, all right? I'm going to give you the answer of 10 workers and 225 students. And we're kind of going to work backwards in this case. All right. And this question asks, what is different about this problem and how does it change your plan? This is how it changes your plan because different information is given. That whole part where it says 215 more students than workers. Because we didn't know how many workers there were. So you use this information to figure out the number of workers. So you may need to pause that so you can write all that information down. So the difference is they gave us the ratio of, the first ratio was 45 students to every 2 workers. So it says if there are 215 more students than workers, how many students and workers are in the lunchroom? You don't even know how many workers you have, but you know that it's going by 2s because every set of 2 you are getting 2 workers. So this one, you will have a ratio where you have to tend to work backwards because you have to know that, okay, if there's 15 more students than workers, okay, so let's do 10 and 225 because there's 215 more. So if you add 10 more, that's the number of students, and if you subtract 215, you will get 10. So in this sense, they wanted you to work backwards. You won't have problems like this often on your test, but we're going to go ahead and flip to the back. I'm going to cover up the word problem because I know you guys can see that on your paper, but I'm going to just read it out loud. The varsity football team is full of juniors and seniors. At the beginning of the summer training, there are 5 juniors to every 2 seniors. After several injuries and new players, the ratio was 4 to 3. If there are 48 juniors on the roster, how many seniors begin the summer training? So let's start by saying what we know. I know in the beginning, I'll put beginning and end. B and E, that's what they stand for. So in the beginning, the ratio for juniors to seniors was 5 juniors, JR, to 2 seniors, SR. All right, JR stands for junior, SR stands for senior. At the end, you have 4 juniors for every 3 seniors. What we need to know is the number of seniors at the beginning. Of the summer. All right, we need to know the number of seniors at the beginning of the summer. If I'm writing too fast or going too fast, make sure you pause the video and catch up, all right? Just don't keep going and get lost. All right, so this is where we're going to plan out our work. I'm going to try to write in pencil just in case I make a mistake. So we're going to have 2 kind of tables going. You have one labeled the beginning, and the other one over here is going to be the end. Right? So we know our chart is going to consist of the junior, senior, and total. Same thing for the end. I'm going to use a different color. We're going to have a junior, senior, and total. All right, so for the beginning, we know that in the beginning there was 5 juniors to every 2 seniors, and that's a total of 7, correct? So now you have to go through a couple of them like the table. So now it's basically like you always are trying to double it, right? So if we double it, because we can't say 6 seniors, it's not going to be 6 and 3, all right? Because every 5, they come in groups of 5, just like the seniors come in groups of 2. So whichever way you look at it, you have to add that same number. You just can't say, oh, 1 more senior is coming. No, because it has to be 2 seniors. 3 juniors can't come because they have to come in a group of 5. So the next set we will have is 10. So if you double 5, you double the 2, which makes it 4, which even makes the answer double. Right, so it says, going back to the word problem so we know what we're trying to find, we're trying to see when there are 48 juniors on the roster. All right, so let's keep going because we have to add another 5. You have 15, double that, that's 8. And when you double 14, if you get confused, all you have to do is add 15 plus 8, and that would, did I do that right? Add 5, oops. You're adding 2, sorry. It's not 8, it is 6. You are adding 2 because this one is getting bigger by 7 each time. So this is 21. So we don't have a total of 48 students yet. So you're going to go ahead and I'm going to start you on the end table too as well. Then I'm going to let you guys pause it and finish it until you can get up to a total of 48 juniors on the roster. So to start with the ending, you have 4 and 3, and we got that from the ending. For every 4 juniors, there are 3 seniors, and this same thing, you still have a total of 7, right? So, again, doubling this, and this will still make it 14. Same thing, you add 4 more, add 3 more. So I want to pause this, and I want you guys to keep going. You may need to write a little bit smaller. If not, you can write on a separate sheet of paper. But go ahead and pause it, and I want you to work out the ones until you get a total of 48 juniors. Okay? Alright, starting on this side, I'm adding another 5. You should have got 20 right here. Add another 2. You have 28. Add another 5, another 2, 35, 30, 12, and this is 42, 35, 14, yeah, 50, is that 56, 42 plus that, that's 49, and 40, and 16, you got 56, and 45, 18, let's see, that is 7, 6, 8. 7 times 8 times 9, so that's 7 times 9, that's 63. So as you see, we're not going to get a total of 48 juniors. So we need to go to the end, all right? So you should have stopped about right here, because you can't, you're going up by 5. So you're not going to ever hit 48. You're not going to hit 48 on the beginning. So let's go back to this chart. We're going up by 4, so this is 16. This is going up by 3, which is 12, and we should get the same. You're getting the same totals that you had over here. So now you have 18, 15, you have 35. So if you were to continue it, you would stop when you get to 48. You'll have 48, and you'll have 36, and you have 84 total players. So the solution is 24 seniors on the team in the beginning. Another way that you could have set it up is the last time when we had the fractions. You know the total, it was 4. Sorry, I'm going to tell you guys a shortcut after doing all the work. So I'm using a scrap sheet of paper. So they said that we're looking at the beginning was 5 and 2. That's juniors to seniors. And at the end, it was 4 juniors to 3 seniors. And you know that they ended up having 48 juniors. So it was 48 juniors. And this is the end, and this is the beginning. We have to kind of find the end and then try to trace back to see how many are in the beginning. Because there are 48 total. These are juniors, and these are seniors. This is juniors, and this is seniors. So we know at the end that the juniors have 48, because that's what it told us in the problem, that in the end there was 48 juniors on the roster. So to get from 4 to 48, you had to times it by 12. 3 times 12 is 36, right? That's the end. But the question was asking for the beginning. So you go to the top and you do the same thing. And when you do that, you do times 12 at the top, you get 60 juniors, times 12 at the bottom, 24. That's how we got our answer for 24 seniors. Okay, that's how you can work backwards as well. I wanted to show you using the table, but you remember, this is the information we had, right? You just had to find the missing piece. Like, we had this information, and we figure out how much it was in between. You just have to solve it using a fraction. All right, last one on the bottom. And you see we have the word problem says, Jenna and Becca were both selling cookies door to door. Jenna sold 8 boxes of cookies for every 3 boxes that Becca sold. Combined, they sold a total of 385 boxes of cookies. How many boxes did each girl sell? So this one is exactly the same. We're going to work this out exactly the same that we worked out the first problem. So what I want you to do is to pause the video, because you're going to do this one completely by yourself. Go back to the problem with the in-state and out-of-state and set it up exactly the same You know how many total boxes. You know how many, the ratio is Jenna to Becca. All right. And for your need to know, you need to know how many boxes did each girl sell. Remember, set it up the exact same way. Line it up, figure out your total. You have to solve two different fractions over the total. All right. So pause it, and then we're going to come back and solve it. All right. So for the information that you know that 8 was for Jenna and 3 is for Becca. And your total is 385. What you need to know is number of boxes for each girl. Now your work, same exact way that you solved the first. So we know that Jenna had 8, and we know that Becca had 3. Oh, that's 2 C's. And you get your total, and your total is 11. So same thing we did in the first problem, right? Let's start with Jenna first. So you take Jenna over the total, and you're trying to get that total of 385. So you know you have to get to 385. So you're thinking, how many times do I have to multiply 11 to get to 385? This is where you take out your calculator. You type in 385 divided into 11. When you do that, you get a total of 35. Oh, sorry, 35. So you know that it's being multiplied by 35. So whatever you do to the bottom, you do to the top. So you do times 35 times the top. 35 times 8 equals 280. So Jenna sold 280. So now you have to go and do Becca. Becca is 3 over 11. And you know your total is 385. You know how many times it takes to get to 385 by 11, which is 35. You do top and bottom. 35 times 3 is 105. All right. So your solution would be that Jenna sold 280. Becca sold 105. And those are the two. This is Jenna right here, and this is Becca. And this is just setting up a ratio. Ratios are such like the same as fractions. The same as fractions. You're usually given the ratio and a total. So now you just do is working backwards. All right. Figuring out how many times does this number go into this one. All right. So this is it for this video. This is homework number 3 that you will be doing. And I'm going to show it. So if you have any questions, I can go ahead and pretty much answer them if I see that it's going to be one that you're going to have problems with. So let me go ahead and pull it up. Give me a second. Alright, so this is the homework. It looks kind of similar to your homework 2. No, maybe not. So same type of, we had a type of problem like this before. You will probably need a scrap sheet of paper, and it gives you you have 8 word problems to solve. For every one, you have to match the correct answer to it. So whatever your ratio is, you need to solve it. So I'm going to move my screen, and I'm going to work out the first problem for you. So give me just a second. Give me a blank sheet of paper. All right. So I'm going to read the first problem first. You can't see it, but just go to your homework page so you can see it. Number 1 says at a local preschool, there's a ratio of 3 boys to every 4 girls. If there are a total of 245 preschoolers enrolled, how many are boys? So your ratio is boys to girls. So it's 3 boys to 4 girls. All right, let me move this down. 3 boys to 4 girls. I'm going to need to do this in a marker. The same thing as writing it as 3/4 when we're looking at it as a ratio, right? So we know that we ended up with 245 altogether. So what you have to do is the same thing in that first problem. So you know that boys, there are 3 boys, and there are 4 girls. That gives you a total of 7 students in all, right? So in order to figure out how many boys there are, you have to do the boys over the total, which would be 3/7. And we know that we have to end up with 245. That's how many total preschoolers are. So then again, you're working backwards. You have to figure out what times 7 will give you 245. All you do is divide 245 divided into 7. And in this case, it's 35. So whatever you do to the bottom, you do to the top. You have 3 times 35. And that is 105. So that lets you know that there are 105 boys, right? 105 boys. So on the bottom for homework, you'll see letters. And as you see that 105 is right there. Let me turn this light off. 105 is right there, and you will write the letter E. So you'll go up to your first problem and write the letter E. Okay? So if you have any questions, let me know, and attempt them first, and then let me know if you have any questions. All right.